Welcome back to Level 6 Math. I'm Mr. C, and today we're doing Saxon Lesson 116. Now, this might be my favorite lesson that we cover all year, and you'll see why in a minute. We're going to be talking about compound interest today, and you can use your calculator on this one. You can also do it without a calculator. It's just going to take you a little longer. I'm also going to show you a way to use spreadsheets. So we haven't pulled that into class yet this year. We're going to look at that today. So when you deposit money in a bank, the bank uses some of that money to make loans and investments that earn money for the bank. That's why banks have business, right? To attract deposits, banks offer to pay interest. It's usually a really small interest rate, but banks will pay interest on your savings so that they can use that money to make more money for them. A percentage of the money deposit, that's what the interest is. The amount deposited is called principal, okay? So there's a difference between simple interest and compound interest. Simple interest we've talked about all year long, like in paying sales tax and things like that. Simple interest is paid on principal only and not paid on any accumulated interest. So if you deposit $100 in an account that has 3% simple interest, you'd take 3% of 100 or $3 each year. Your $100 was on deposit. So if you have $100 in after a year, it makes 3%. Now, banks aren't typically going to pay 3% on savings. That's really generous. Historically, they're going to pay closer to 0.5%. But let's say they were paying 3%. After a year, you'd have $103, but after 3 years, you'd have $109. So it looks like this. Principal, that's what you put into the bank. After 1 year, you make $3. After 2 years, you make another $3. The third year, you make another $3. So after 3 years, you make $109, which is great. You're getting that money for free just by having it in the bank, letting them use your money. But let's look at what happens if we compound that interest. So in most interest-bearing accounts, compound interest happens, and that's the interest paid on accumulated interest as well as principal. So this is what that's going to look like. After 1 year, you have $103. Now, instead of getting 3% the next year just on your principal, you're going to get it on your total amount, which is 103. So the second year, you're going to get 3% of that, which is $3.09. So you get that extra 9 cents, which doesn't seem like a lot at the beginning, but that's why it's called compounding. It's bigger over time. So the next year, now you have a total of 106.09. You take the interest on that, and that's going to be 318 the next year. So it just grows more year after year. So after 3 years, now you have $109.27. Now you'd say, we only made an extra 27 cents by having compound interest. That's not a big deal. Well, I'm going to show you a spreadsheet later on that shows how it can be a very big deal. All right, let's look at an example first. Mrs. Vasquez opened a $2,000 retirement account that's grown at 10% a year. Now, 10% is the historical average on the stock market. So if you got what the stock market returns year over year over 3 years, now the stock market is volatile. That means it goes up and down quite a bit. And so there's no guarantee you're going to get 10% a year. But let's say she can lock in at that rate. Maybe there's a great deal going on and they say, we guarantee 10% for 3 years. What's going to be the value of her account? Well, what we're going to do here is we're going to take 2,000 and we're going to multiply that by 10. So what that will look like is we'll take 2,000, we'll multiply that by 10%, which of course is 0.1. And we can do this with our calculator. So you just type in 2,000 times 0.1, and our total is going to be $2,200. So she's going to make $200 by getting 10% interest on that for that year. Now the second year, she's going to take the 2,200, multiply that by 10. So step 2 is now enter 2,200 times 0.1, and the result will be 2,420. So now she's making an extra $20 just off interest on the interest. All right. Then the third year, she takes that 2,420, multiplies that by 0.10 or 0.1, and she gets $242 increase, adds that to the total, and now she has $2,662. You can see how if she'd used simple interest, she would have got $200 a year, so she would have had $2,600. But by having compound interest, now she gets that extra $62. Now, this is just going to say the same thing we just went over, so I'm going to skip over this. I want to get to the spreadsheet. And this is just how to use a calculator. 2,000 times 1.1. that's going to make it so you don't have to add it up year after year. You'd say 100%, that's 1.1, that's the 0.1 that you had. So rather than taking two steps, we can just do 2,000 times 1.1, and that will get you your 2,200. If we times that again, we have the 2,200 already up on the calculator and multiply that by 1.1. Now we're going to get 2,420. And if we keep pressing that, that will show us year after year how much it grows. So we can times 1.1 again. If we do times 1.1 again, it will just take us to the next one. So you can keep doing that a bunch of times, which is cool. And some calculators, like graphing calculators and stuff, they have other function keys that will allow you to do this even faster. All right, so that's the lesson. Now let me flip over. I'm just going to show you how cool this is if we extend it out. So I made a spreadsheet, and I'll show you how I made it, but let's just look at it real quick. All right, so here's some compound interest examples. I took an 11-year-old, or someone who was 10, after 1 year they're 11, so that will be 1 year, and let's say they invest $1,000 for the rest of their lives, till they're 100. So we're going to invest that for 90 years and see what happens. Now, if they just have principal, after 90 years, they'll have invested $90,000, which is pretty good. I mean, that's more than the average adult American saves for retirement currently. So if they just saved $1,000 for their whole life, they'd have more than the average American, which is awesome. And that's with no interest, getting nothing back, just putting that in a piggy bank, sticking it under the bed, socking it away. $90,000, which is pretty cool. If we take 1%, just 1% interest, and we compound that, you'll see that by time that person is 30, they'll now have an extra $239.19. So just by getting 1%, so if they put it in a savings account that only got 1%, by the time they're 30, out of college and starting to work, they're going to have that extra $239. Now, that's not very much, and actually inflation is higher than that, so the earning value of that money is going to be worth less than the original amount. Typically, you want to keep up by about 4% a year. So that's not going to be good enough. If they get a treasury bond, so this is giving the government money and locking into a low interest rate, those are called bonds. You can usually get about 3% on a treasury bond. So if they did that by the time they're 30, instead of 20,000 or 22,000, now they have 27,600. So that's going to bring you a lot more. If they put it in a mutual fund that's actively managed by someone else and has high fees, 5% is a reasonable expectation to get a rate of return. That would be 34,000 after the 20 years. So when they're 30, 34,000. Now, if they got the index fund, and that's what all the stock market does together, again, historically it's been about 10%. If they got a 10% return on investment, look what they're going to have, $63,000. And that's just by age of 30. So investing $1,000 a year, they're going to make $40,000 just on interest. That's amazing. Now, it's possible to make more, and I put this just for fun. You're not going to likely make more than 10%, but let's say you do speculative funds, you hit a few home runs in the stock market, or you invest in companies as a venture capitalist, and you're getting 15%, that's going to be $117,000. Now, here's the craziest thing. This works both ways, right? You can invest money, but you can also spend money and have debt. And a lot of Americans do this. They take out credit card debt, and credit card companies can charge as much as actually more than 26%. But I put 26% because that's commonly talked about in the literature as, if you have credit cards, they're going to charge you a lot. If you just put $1,000 on your credit card every year and didn't pay any of that off, but just accumulated the interest, it'd be almost $500,000 after just 20 years. $500,000! Oh my gosh, no wonder so many Americans are in debt. That is crazy sauce. All right, so this is interesting to look at, but what if we extended that out to retirement? So again, $1,000 a year, all the way till age, we could look at 62, 67, 72. That retirement age keeps creeping back because we're growing older and older and older as we get older. So let's look at those three benchmarks. All right, here you see by age 62, if you've invested $1,000 a year at 1%, you're going to have $68,000. At 3%, that'll be 125. At 5%, $250,000. At 10%, $1.5 million at retirement. If you just invest $1,000 a year and get historical returns, you'll have $1.5 million. What about 15%? $10 million. Oh my gosh, you could do really, really well investing $1,000 a year. Credit card debt? Almost $1 billion. $800 million if you had 26%. Oh! 67 is kind of the new retirement age right now, and if we looked at that across the board, you'd see at 10%, we're looking at $2.5 million. So that's actually a realistic estimate. If you could invest $1,000 a year, put it in a long-term stock fund, and guess what? I know this is possible because I have a 15-year-old, and he works really hard, and he mows lawns and does things. He has saved $1,000 a year and has invested it in the stock market. He has several $1,000s now as a teenager, and he just bought his dream car, a 1967 Ford Mustang. I know it's possible. It's hard. As parents, we didn't give him any of that money. He had to earn it. He's worked in the neighborhoods and done things. So this is possible. He's on track right now to have, at age 72, $4 million. Not too shabby, $4 million at age 72. And that's what I think retirement age will be for kids that are right now 10 or 11 years old. If we extend this, let's go all the way to 100 years old just to see. All right, here we go. If you invest for 90 years, you'll have invested $90,000. If you get 1% return on investment, that will have grown to $146,000. 3%, $500,000. 5%, $1.5 million. 10%, $58 million by the time you die. So if you just socked that away and didn't use it, save other money for retirement, but just socked it away, you could donate $60 million when you die. If you got 15%, that would be, let's see, $2 trillion. Yep, $2 trillion. That's not too bad. And if you had credit card debt, that would be whatever's more than trillions, 5 of those. So like more money than I can comprehend, you'd have. It'd be like the biggest debt ever. And no wonder our national deficit's so huge, because we keep borrowing and creating and inventing new money. All right, now let me show you how I built this spreadsheet. I'll just do that really quick and then we'll sign off. You're going to come back to the top and just click in a cell here. Okay, here's what I've done. And there are tons of videos on YouTube that will show you how to do this. I take $1,000 and I want to see how much interest rate that has. So what I do is I take D4, nope, that's not right. Oh, because I can't see the cells over there. Let me scroll over. If I can on this screen. Oh, it doesn't show it. Okay. I'm just going to take this one because it's easier to show how I set it up initially. How did I get that $1,000 and change it to 1,010? This is a simple calculation. You simply say C4, C, and this is going to be C4 on this thing. You can't see the button there. But we take C4 and we times, that's just the asterisk symbol, 1.01. So just like we did on our calculator, we do that, hit enter, and then it automatically makes that $1,010. Now if I take this bottom right corner and I just drag it down, it'll apply that to everything. But I want to change the formula here because now I want it to compound. So I want to add the $1,000 and then multiply that by 0.101. So the way I do that is I take my D4, this amount, I add it to the new principal amount, $1,000, and then I multiply both of those by 0.101. Now remember, when we're multiplying multiple things or adding things and then multiplying, we want to make sure that we have parentheses so that those things add first and then it multiplies the total amount. So that's why it's parentheses around those things. Then you can just take that and I dragged that down and that created all my values. So I created this whole spreadsheet in not very much time, maybe 15 minutes, because I just had to figure out how to do the different amounts and how to add them, and then I just drug them down to copy the formula that I've created. this is a really cool thing about using spreadsheets, is that it can give you all that information. And so this is why I love compound interest. It's fun to think about what you can do over time if you compound your money. It's a way that a school teacher like myself can realistically save for retirement. If it's just a little bit a year, you can do that, and you can save up to buy a house or get a fancy car or have that money in the bank for retirement. So I hope you have fun working on your compound interest today. We'll see you next time.